Have you ever wondered what happens inside that balloon when it expands or shrinks? Or how a simple can of soda fizzes when you pop it open? Welcome to the fascinating world of gases. Today, we're diving into the combined gas law, a scientific principle that connects the dots between pressure, volume, and temperature. This law is like a magic recipe, blending three key gas behaviors into one powerful equation. It helps us understand everything from how airplanes soar at high altitudes to why your car's tire pressure changes with the weather. Join us as we explore how the combined gas law shapes our everyday lives and unlocks the secrets of the gases all around us. Before that, what is combined gas law? Combined gas law relates how three properties of a gas, pressure, volume, and temperature relate to and change with each other.
Hey Janella, I've heard we can demonstrate the combined gas law using candle, some water, and this container.
That's right! It's a great experiment to understand how gases behave. Plus, we can connect it to real-life applications afterward.
So what's the first step here?
First, light the candle and place it in a container with water. This will heat the air inside. As the candle burns, it heats the air inside. According to the combined gas law, when the temperature increases, the pressure should also increase if volume stays constant.
But once the candle consumes enough oxygen, what happens?
Right. As the candle uses oxygen, the pressure inside the container drops. This creates a vacuum effect.
Exactly. The higher external pressure of the water pushes it into the container to balance the decrease in pressure.
Wow, look at that. It's like magic.
It's science. This illustrates the combined gas law. As the volume of gas decreases, the water level rises.
This is cool, but how does this relate to real life?
Great question. A classic example is a balloon. When you take a balloon from a warm room into a cold refrigerator, its volume decreases. If you then pop it back to its original size, the pressure inside will be lower than when it was first inflated.
So, understanding these laws help us in many areas of everyday life.
Exactly. Science is everywhere, and experiments like this make it clear how interconnected everything is.
Thanks for the awesome demonstration, scientists. I can't wait to tell others about it.
As we wrap up our exploration of the combined gas law, let's reflect on a simple yet captivating experiment involving water, a candle, a glass, and a container. When we place a lit candle inside a container with water and cover it with glass, the burning candle heats the air inside, creating pressure. As the candle uses up oxygen, the air cools and the pressure changes. This fascinating interaction illustrates the principles of the combined gas law. As the temperature of the gas inside the container decreases, the volume of air contracts, causing a drop in pressure. Eventually, the candle goes out and we see the water level rise in the glass, demonstrating how gases and liquids interact in this closed system. In this simple demonstration, we've witnessed the combined gas law in action, highlighting its real-world applications and importance in understanding how gases behave under different conditions. So, whether it's a candle, a glass, or the water inside, remember that the dance of pressure, volume, and temperature is always at play in our everyday lives.
This law is particularly crucial in fields such as chemistry, physics, and engineering, as it lays the groundwork for understanding gas behavior in both natural and artificial systems. Remember, whether you're solving real-world problems like calculating how gas behave in a hot air balloon, understanding respiration in biological system, or designing engines that rely on gas law, or grasping the underlying concept in chemistry, the combined gas law is an essential part of your scientific toolkit. To consolidate your understanding, I encourage you to engage in hands-on experimentation. For example, try observing how sealed container of gas behave when heated versus when it's cold, or apply the law to calculate the change in volume of a gas as pressure adjusts. This practical exercise will reinforce your learning and build your confidence. Thank you for joining this tutorial. Keep practicing with real-life examples and challenges to master your skills. Happy experimenting and enjoy your journey through the fascinating world of gases.